Okay, good morning, everyone. Good afternoon, good night, and also, I think, very late night for some of you. We are very, very happy to welcome you to this second webinar of the series organized by the CIPA Heritage Emerging Professionals in partnership with ICOMOS, the ICOMOS ISPRS CIPA Heritage Documentation Scientific Committee, and the NSERC Create Heritage Engineering Program from Canada. Now, I am talking to you on behalf of ICOMOS, and I want to mention a few things. I only have 5 minutes. So I am preparing an article for UNESCO about the issues about technology and COVID-19. And I was thinking that actually the webinars are very relevant to this purpose because we have confronted in the conservation of cultural heritage, we have been confronting a lot of challenges. A few years ago, we were looking at the destructions happening in countries in the Middle East by conflict. And we felt that we had, those places were out of reach for us, and we mobilized technology to be able to record those sites, to be able to get information from them. Then even if we go even farther, even backwards, I would say, we can look at Abu Simbel in Egypt and how the international community mobilized themselves to be able to protect this. And I think that the pandemic situation is no different to this. And we have a lot of challenges, but we also have a great opportunity to help each other and to serve the community. And I think that the webinars organized by our emerging professionals are an important contribution to that end, because we're not only mobilizing the use of technology, but we're also mobilizing the use of technology in a conscious way. So the first webinar, we were talking about accessing heritage places from home. And today we're going to talk about low-cost techniques for heritage recording and visualization. So they are very linked. And then the third event will happen probably in June the 4th. And we will be talking exclusively about virtual reality. A little bit like this one, low-cost techniques, but more into virtual reality. And then we're going to talk about ethics. But I would be spoiling the fun of looking forward to the new contents. Now, ICOMOS, one thing that I want to make clear about ICOMOS is a non-for-profit organization, which is completely formed by volunteers. So everybody that you're going to see here are members of ICOMOS or are collaborators, and we are all volunteering our time to do this. And I think that this is another very strong point. Now, we have people from the Government, Public Services and Procurement Canada, and then we have professionals and researchers from many academic institutions like Penn State University, the Universidad in Turin, the INSEE Strasbourg, CloudCompare, and the National Technical University of Athens. And they have been putting their time to talk to you this morning. So I would also like to thank them, but I also would like to thank their organizations that are given the chance for them to be able to participate in this event. So, and one final thing, ICOMOS is not alone in CIPA. We also have ISPRS. ISPRS is the International Society for Remote Sensing and Photogrammetry. And ISPRS is an organization, it's also a non-profit organization that is more in the area of surveying. And the strength of CIPA comes from these two ends. So we have ICOMOS, which is conservation specialists, and then we have ISPRS, who are technicians in surveying. So we all welcome you to this great event today. So back to you, Becca.
Mario, thanks for your welcome address. My name is Rebecca Napolitano, and I'd like to welcome you all on behalf of the CIPA Emerging Professionals to the webinar, Low-Cost Techniques for Heritage Recording and Visualization. We hope that during this period of severe and unforeseen circumstances, you and your families are remaining safe and well. Some of the main topics that we're going to cover today are photography, multispectral imaging, photogrammetry, point cloud processing, and GIS. And here you can see an agenda. Each of the speakers will be introduced by me and present for 25 minutes. Following their presentations, they will be taking questions from the audience. After that, there'll be closing thoughts from Grazia Tucci. You can express your queries and thoughts only through the Q&A link. I have put the Q&A link into the chat, so everyone should be able to use that in order to submit their questions and upvote each other's questions. We also want to inform you that no offensive language, spamming, or mansplaining will be tolerated during this webinar. Please mute your microphone to help keep background noise to a minimum during this, and switch off video to improve network bandwidth. Only the speakers should have their video on at any point. So without further ado, I would like to introduce Christian. Stop share. Christian, do you want to share your screen?
Okay.
So Christian OUIMET is an architectural conservation technologist with the Heritage Conservation Directorate. He's worked on various documentation projects from large industrial sites to topographical battlefield terrain, such as the Canadian First World War memorials in Europe. He's been a lecturer at the Université de Québec at Montreal and taught at the Arlemar International Center for Conservation, the University of Pennsylvania, and Carleton University. Without further ado, Christian.
Thank you, Rebecca. And I know that you mentioned that each presentation is 25 minutes. Mine will actually be much shorter. It'll be about 5-6 minutes. So the idea is to give like a foundation, or like most of the other presentations will deal with photography, either to take photogrammetric images, etc. So the idea was just to provide a really basic overview of what to consider when you're taking photographs for these various projects. So here I just have an overview of the various tools that you can consider when you're taking photographs. So the most obvious one is you need a camera. And I reluctantly put a smartphone here. We always say that, well, really you should have like a digital single lens reflex camera, or a mirror, like an in-between point and shoot camera as a minimum. But I do understand how accessible smartphones are. And if that's the only tool you have to, well, feel free to experiment with that. The second consideration is lighting. The third is camera support. By that, I mean, like, it could be like a tripod, but especially for photogrammetric means, well, today we have more and more the use of UAV or drones, but you have telescopic poles or mast, crane, or to take pictures from a different vantage points. You can use kites, you can use weather balloons. There's a lot of various options. And then when you're post-processing your images, we're saying that this is a low-cost tools and techniques, so Photoshop might not be in that category, but there are open source software as well to edit images that's available. So I'm just highlighting in red here the minimum that you need really to take photographs for either record photography or photogrammetry. So obviously you need a camera, and fortunately sunlight, and or if it's cloudy outside, that's free lighting available. And if you're indoors, well, you have to consider the available light there, either incandescent light, fluorescent, LED, etc. And a tripod could be quite important as well. It's not always necessary, and I'll explain when it is necessary later on in the presentation. But I've got some advantages here listed for when to use a tripod, or how it can help you with your project. I would say the main disadvantage is it can really slow your process down, especially when you're taking hundreds or sometimes thousands of images for a photogrammetric project. You can't expect to set up for each photo with a tripod. So there are solutions around that. So the presentation, I want to go through first the equipment. So I've gone through that. The next thing is the lighting and exposure. So this isn't by no means to be a photographic course, but I just want to highlight a few things that you should get familiar with if you really consider this in your careers. It's worth the investment to get familiar with your camera's manual functions. So the two main functions I'll focus on is the shutter speed and aperture. And those controls, especially with sort of the more advanced cameras, but even in some of the smartphones, you can see these controls and manipulate them by yourself. And by getting familiar with your camera, different cameras, companies have slightly variance in how to access those options. So it is worth getting used to or to experiment with manual settings. However, if you only occasionally take photos, there's nothing wrong in just putting your camera in a program or an automatic setting. So when you do that, you're basically letting the camera decide and the computer on board what the appropriate exposure is. Manual setting, you make the decisions. For aperture, so the aperture is similar to the iris of your eye. So the bigger the opening, like the image below here, the more light is entering the camera. And the smaller the opening, the less light is entering the camera. So the advantage of a small aperture is that you have a greater depth of field. So by depth of field, what I mean is in this zone, things are in focus and things in front of the zone or behind it will appear slightly blurry. For the next thing to consider for a proper exposure is the shutter speed. So fast shutter speed, it's like you're capturing movement. In this pinwheel, we can see the pinwheel that's spinning the same speed as the last one. We're freezing the movement of the pinwheel. And the last one, it says a half a second exposure, and compared to 1/250th of a second exposure, we can see the blurriness or the movement of the pinwheel. So if you put your camera on a half-second setting, you can actually hear the shutter open, you'll hear it click, and a half second later, you'll hear it shut down. And that's the time the curtain's allowing the light to enter your camera to hit the sensor of your camera. Fortunately for us, buildings or monuments don't tend to move. So if we have a tripod, we can use any of these shutter speeds. And I want to come back to the use of a tripod. So when do you need a tripod to minimize camera movement or blur as a result of camera movement? So the one thing if you can remember from this presentation is that with an SLR camera, if you use a 14mm lens, the rule of thumb is if the number is 14mm, and usually you can see this by written right on the lens, your shutter speed should be no less than 1/14th of a second. So in most cameras, 1/15th of a second would be adequate. And I'm going to the extreme here with the 600mm lens. 1/500th of a second would actually not be adequate because 500 is less than 600. So you'd have to go to a 1,000th of a second shutter speed. When using a lens, especially for photogrammetry, fixed focal lenses are generally better than variable lenses, although the two with some software will work. And from my personal experience, acceptable focal lengths for photogrammetry, it could be in the range of between 14 and 85mm, but now you have photogrammetric projects being undertaken with panoramic images, so that is just from my personal experience. If white balance or the color temperature of your image is important to record, you do need to consider using like a color card or a gray card. Basically, you want something that's neutral in the scene. And with software such as Photoshop, and there's other out there, you can pick that neutral color, and then it'll correct for the color temperature of the scene, depending if it was sunlight, a cloudy day, etc. So in conclusion, I just want to conclude with some basic guidelines when you do take photography for photogrammetric projects is that, and these rules are the same for the last 150 years since photography and a bit later on photogrammetry was invented. But firstly, your subject has to be properly exposed and focused. So it's basically if you get poor images, you're going to get poor photogrammetric results as well. I talked about this. When possible, keep the focal length and focus distance the same. Some of the other presenters might talk more about the image overlap, what's appropriate for that. But the level of detail and accuracy is really judged in a function of basically, if the closer you are to the subject, the more detail and accuracy you'll get, the further away you are from the building or monument, the less accurate it will be. And your lighting should be consistent and uniform. And a lot of photogrammetric softwares or methodologies will say that you should avoid using flash photography, but there are instances where that can be appropriate and will work, especially with fixed lights. So that's everything, and thank you for your time, and thank you for the invitation for me to present this. I'll release my screen.
Great, thanks so much, Christian, for your great presentation. Do we have any questions from the audience at this point for Christian in terms of what he presented? I think we can take one or two. I'll place the link again into the chat box in case someone missed it.
Hi, it's Michelle here. I'm just going to read out one of the questions. Do I need to have a specific type of camera to do photogrammetry?
Well, that's a good question, because in the past, I would say, if we'd be 20 years ago, definitely, yes, you needed like a metric camera, ideally, that had like a close to perfect lens and really known parameters. Today, with the various photogrammetric software, it actually figures out those camera parameters and distortions that are in the lens, in the sensor, etc. So the answer is you can use, I mean, I've seen projects or students in some cases use a smartphone to do a photogrammetric project and with some okay results. So I would experiment if you're interested in this field. If you do have access to like a low-cost camera or a higher cost one, and you replicate the same scene, taking the same pictures, you can compare the results and see the pros and cons as far as the type of camera that you need to use. So the short answer is no, there's not necessarily specific ones. But you should follow the rules, being that you should ideally have a fixed focal lens if you can, instead of a variable lens, and consistent focus distance and focal length.
So hello, it's Joe here, and I'm going to go with one more questions from the audiences. Sorry. Okay. If you are taking photos outdoors, how can you compensate for daylight variation, sun, overcast, etc.?
Yeah, that's a challenge, because if it keeps, especially on a cloudy day, if the clouds cover up the sun and the sun comes back out, then you have photos hitting the surface of the wall, let's say of an elevation, that are in sunlight, and some of that are in shadow and different exposures, etc. So that is a challenge. If you have the luxury to be at a site any time of the week, let's say, looking at the weather forecast is a good way to plan out your campaign. So if it's going to be cloudy all day in the morning or something like that, then you try to plan to take the photographs of that facade at the same time and as quickly as you possibly can. If it does vary, sometimes you don't have that luxury. Shooting your images raw and trying to do your best to get the most consistent exposure will be the only thing that you can do. And then when you're back in your studio or office, you can group the pictures, but the ones that were taken in sunlight and the ones that were taken in cloudy conditions, and adjust the white balance of those images based on those conditions, and then recombine them together.
Great, Christian, thanks so much for your responses. So that way we can keep with time. I'm going to move on to our next speaker, but please feel free to add questions and upvote questions in the link provided. So our next speaker is EFSTATHIOS ADAMOPOULOS. He holds an engineer's diploma in rural and surveying engineering and a master's degree in protection of monuments. He's currently pursuing a PhD degree in new technologies for cultural heritage from the University of Turin. His current research involves multispectral and non-visible wavelength modeling and data fusion for the enhanced documentation and diagnostics of tangible heritage. Without further ado, EFSTATHIOS.
Thank you, Becca, and again, welcome everyone. So briefly, my points will be about sensing beyond the visible for heritage, spectral imaging and applications, image cubes and how to get them, low-cost spectral imaging, and some basic image processing on that. So most commonly, we associate the visible spectrum, which represents a very narrow portion of the electromagnetic spectrum, with the acquisition of information for heritage, because usually we use them for 3D modeling or simple photographic documentation. Although for many applications like inspection of archaeological remains, integrated diagnostics, study of artwork, archaeometric investigations, we require information collected in various other wavelengths and not only in the visible. Its application of heritage science requires specialized instrumentation and often complicated apparatuses and expensive sensors are employed for specific applications, which makes on-site risk assessment or rapid evaluations or remote assessing of heritage quite tricky, mainly when limited resources are available. To tackle these issues, we implement various imaging techniques, not replacing but accommodating the more complicated ones. And here in this diagram, you can see some sensors operating on different spectra. For example, normal visible spectrum cameras in the visible, then ultraviolet and infrared in the near visible spectra, X-rays, thermal imaging, various radars for underground prospection to investigate buried remains and other types of sensors, even in the sound waves. So the acquisition of imagery in the form of remote sensing or images taken from airplanes, from UAVs, or from your normal terrestrial applications with consumer-grade cameras provides a significant amount of data towards heritage protection. This can be interpreted to comprehend phenomena relevant to the historic path of heritage assets, their current state of preservation, to provide reference systems so as to fuse different data, and even to investigate underground remains and explore subsurface defects. So within specific wavelength ranges across the electromagnetic spectrum, from its wavelength range, we can extract different types of information. Here I summarize some applications. So every column is a different spectrum, and every line is a different range of applications. The first line is large scale, like archaeological remains, when we can do some kinds of prospection. The middle one is facades or rock art or wall paintings. And the bottom one is artifacts or artwork. So you can see that there is some overlapping between some of those applications. But there are some other attributes that can be characterized only on specific wavelengths. In the optimal case for our object of study, we could have hundreds of images captured on contiguous spectral bands. This technique is usually common for remote sensing, and it's hyperspectral imaging. And the product acquired is called the hyperspectral cube, basically a stack of a big amount of images on very narrow spectra of the electromagnetic spectrum. But, of course, there are some specialized equipment to simulate this for terrestrial applications, mainly for artwork, but there are very complicated sensors. We can simulate this by using simple cameras and with specific filters taking image data from wider spectrums. So a lot of less stacked images, but we can have it on a very much lower cost. So recent introduction of cameras that are off the shelf, consumer grade for everyday applications that can be modified for near infrared or ultraviolet imaging, made spectral imaging more feasible than ever. Basically, by modifying a camera intended for everyday use, you get a low-cost alternative for spectral imaging, which retains its user-friendly features and interfaces to photographic accessories or software. Thus, it can be...
I don't mean to interrupt, but I just wanted to let out your participant bar with the videos is over some of your graphics. So if you wanted to hide that, we'd be able to see. No, you're fine. I figured you want to know.
Okay. So if we use a simple camera and an infrared modified to take images on UV and visible and near infrared spectra, using filters, we can separate those and take one near infrared filter to take only near infrared image, one for visible, one for ultraviolet, and then stack them all together to make an image cube like we would get with a more expensive sensor. So for the demonstration I'm going to show, I used a used Canon camera modified for full spectrum acquisition and external filters for ultraviolet, visible, and near infrared imaging. The total cost of the camera with the modification and the other accessories is under $600. And also the software I'm going to use is a freeware hypercube, which is intended for multispectral and hyperspectral data, but we can use it also for consumer everyday images. And so let's go to the demonstration. So this is the interface of hypercube. We can open different data types of images from simple JPEG or even raw data or even multi-band, multispectral data. So for our first example, I will use a visible image from a Chinese Coromandel screen panel. And then I will open the near infrared image. So what we want to do is separate the visible image into red, green, and blue, and then add on that the near infrared to create a stack of images. So first, we want to convert the near infrared image into a single band image. So convert image, gray, and then add this band to the other 3 bands of the visible. So we need to convert the visible image to 3 bands, red, green, and blue. Or we can make a cube of the different colors. So color to cube, add BGR cube, and we have a set of consecutive bands. Then adding after the red, the infrared channel, we will create a cube of 4 stacked images. So add to cube and add last after the red band. And now we have stacked blue, green, red, near infrared. And that's the simplest way to acquire the image cube with just 4 spectra. Of course, in order to do that, you have to take images from the same positions with same geometry so that they are exactly overlapping, let's say. There are no geometric differences between the different bands. And we can process this cube by, for example, converting this by principal component analysis, which is basically getting out the most of the information that we can get. So I don't want to get into more technical details. So here is the first channel. We can't see anything different from the visible one, probably. But if we go to the second one, you can see probably all the subsurface defects here and in this area, and all the retouchments on this artifact, on this artwork. So let's do a second quick application. So now I'm going to use orthophotos, and so that we are sure we have the same projection of the object. Here is the visible, then I have the ultraviolet, the near infrared, and the thermal one that I acquired with a low-cost camera that can be adjusted to a cell phone. You can see that the resolution is not very good, but let's see what we can get out of this. So we convert again the visible image to a color cube. And then add each individual, convert to single band, and add each individual channel. Here we're clicking first because UV is before the blue channel, and then the near infrared after the red channel. And then the not so good thermal. So image compared to A. And you can maybe see vaguely the moisture content in this section, which is in darker gray scale. And again, add that to cube, last. And we have now a color cube, an image cube of 6 bands. UV, blue, green, red, near infrared, thermal. So again, if we try to get most out of this, the most information possible, maybe on the first one, you can't see much, or the other one. Here, maybe we can observe the darker areas that correspond with weathering. And here, the lighter areas are corresponding to rocks that have been changed. And maybe, and the lighter one corresponds to the biocolonization. You have to ignore the shadows because it was taken under very unstable conditions. And you can see that the last results do not provide anything. It's just the noise, probably for shaking of camera, blurring, or the thermal data. I don't want to take more of the time, so let's stop here, and thank you very much.
So it's Joe here again. Thank you so much, Study, for your presentation. And I'm going to ask you one question of, it's okay, from the audience. So the problem with hyperspectral imaging is that spatial resolution is not as high as RGB cameras. Therefore, the data is very mixed. What do you consider to be the best unmixing algorithm for hyperspectral data?
Oh, that's very advanced and actually not my topic, because I don't use remote sensing data, only terrestrial
not
data.
a problem. I'm gonna skip it and go for another one. Can the feature you showed in Hypercube can be done as well in Image J? Is there any special functionality that Hypercube adds?
In Image J, I haven't used Image J. The problem with most of the free software for that type of processing, which are not many, is when you don't have images taken with the same geometric properties, you have to adjust them, you have to register them. So you can't do that with every software, and not many of them can how to say it? They don't have all the processing algorithms that would usually be used in terrestrial data. You have to do some programming. Of course, this does not work very well with if you want to extract images and then use them for photogrammetry, because there are a lot of distortions. I hope I've answered, but we can redirect more technical questions to our forum. And
okay, Sadi, just one more question. What kind of post-processing you do with UV light photographies?
Usually nothing. I just insert them as they are, and especially for I'm trying now to use directly ultraviolet images from very long exposures and near-infrared images to do directly 3D modeling, not use the visible images and then project the other information. So of course, for that, I'm using the raw data. I'm not using the ultraviolet images for as a specialist on conservation, so I can't answer on post-processing the UV images as a single type of information for extracting data. I think that's it.
Okay, yeah, thanks, Stathis, for your presentation. It was very informative, and I know that there are a lot of other questions going in the Q&A, and maybe we can do something to answer some of those after, but thanks very much for your presentation. The next speaker that I would like to introduce is Arnadi Martioso. Arnadi holds a bachelor's degree in geodesy and geomatics from Bandung Institute of Technology and an engineer's diploma in topography from the National Institute for Applied Sciences, Strasbourg. He's currently pursuing a PhD in photogrammetry and geomatics from the University of Strasbourg. His current research involves photogrammetric, bundle adjustment, point cloud segmentation and classification, and automation in 3D modeling for heritage objects and sites. Arnadi, please.
Yeah, thank you, Rebecca, for the introduction. Can you see my screen here?
Yes.
Yeah.
Yes, yes.
Okay, thank you. Thank you for the opportunity. So I will be presenting, so I have 25 minutes.
Yes, 25 minutes.
We might. Arnadi, I think there's something wrong with your presentation. We can't hear you. I don't think you're on mute. I can't unmute you now. Do you still hear us? Arnadi? Okay, it seems that Arnadi might be having technical difficulties. And so if we're not able to have Arnadi now, I would like to invite Daniel Girardot-Monteau to start his presentation.
Hi. Yes.
Daniel, can you share over what Arnadi has up right now?
I'll try, yeah.
His laptop crashed, so he's not able to fix it.
Okay.
While you're figuring that out, I'll introduce you to the participants here. So Daniel Girardot-Monteau is a former scientific software developer specialized in image and 3D data processing. He's the creator and main developer of CloudCompare, an open source 3D point cloud and mesh comparison tool that's very well known in the field. Former Chief Scientific Officer of Orthotaxy, which is a startup now part of Johnson & Johnson. Daniel?
Yes, thank you for the introduction, and thank you, by the way, for the invitation. So as you said, my name is Daniel, and I'm the main the administrator and the main contributor of the CloudCompare project. So I started this project something like 15 years ago during my PhD. CloudCompare at the beginning was mainly meant as its name.
Daniel, I apologize. We are not seeing your screen. We are still seeing Arnadi's screen.
Even though, Zoom is stating that I am sharing the screen.
Now I can see your screen.
Okay, it worked. Yeah.
Yes.
Okay. So anyway, it was just CloudCompare, you know, the default view of CloudCompare. I didn't want to make a presentation due to the fact that I don't have that much time, and I think it would be more interesting to present people like useful stuff, especially for those who don't know CloudCompare yet. Yeah, so as I said, CloudCompare is meant to, was meant at the very beginning mostly to compare point clouds, dense point clouds from terrestrial laser scanners at that time. We could compare them, you could compare a point cloud to another dense point cloud. That was the whole, the main interest of my PhD. But we still had the option to compare a point cloud to a triangulated mesh. And this is where everything started, from this comparison capability. Then, because I was working at that time for a big company named EDF, which is the main French power utility, which had, you know, dams, nuclear power plants, and stuff like that. They had many applications, so it was a good opportunity for me to test various things, develop new tools. It could be very serious stuff like building monitoring, landslide monitoring as well. But I had also had the chance to work on archaeological projects thanks to EDF. And this is how CloudCompare became more and more stuffed with tools. And CloudCompare, I mean EDF, which was my employer at the beginning, accepted to make CloudCompare open source around 2010. And this is how, yeah, the aim was to make it, you know, available to the widest community, so that it can be useful. And I hope it's useful. Apparently, a lot of people are using it today, which is great. So let me start the presentation of CloudCompare. So for those who don't know the software, it has this very, well, I want to say standard GUI, graphical interface. I mean standard in when we deal with 3D point clouds, 3D data, sorry. Sorry, there are a lot of icons. We have a lot of tools today and a lot of plugins. We have on the left side what we call the DB tree, for database tree. This is where all the data, all the loaded files and its contents is displayed. Above that, you have the properties sections, where you see the properties of the highlighted entity, and in the middle you have a 3D view, of course, to display 3D entities. First, generally, you need to open files. CloudCompare. So, sorry, I went a little bit fast. The open icon is on the top left. That's probably the most useful. You also have access to it via the open menu, sorry, the file menu. So you can click on that. This is a very standard open dialog. It's interesting because here in the filters, you can have an idea of all the formats, the file formats that CloudCompare supports. It has its own format, which is the bin for binary format, but it's really dedicated to CloudCompare. The good thing with the bin format is that you can virtually store anything, any kind of data that was imported or generated in CloudCompare, any kind of entity, and you can regroup them in this file. So it's kind of way to save projects in CloudCompare. The only issue is, of course, that only CloudCompare is able to load this file. So if you want to export your results or your clouds or meshes, you may think again and use another format. So speaking of other formats, we actually manage a lot of formats. The most useful are probably at the beginning. So you have ASCII point clouds, which are text files, very simple. We'll see that you can load quite a lot of text files. LAS, of course, E57, which is also a very interesting format. PTX, let me see, PLY, which can handle both clouds and meshes. And then you have some quite standard mesh formats like OBJ, STL, and so on. So I won't spend too much time, but yeah, there are quite a lot of formats. Normally, you should find what you are looking for. And since CloudCompare is open source, it's always possible to add your own format, but I won't expand over that. So you have the option to do it like that. Another option which I prefer is to simply drag and drop a file from your Explorer. So you probably don't see my Explorer, but I let you imagine that I am currently dragging a file and dropping it over the 3D view. CloudCompare will automatically deduce the format from the extension. So this is from an archaeological project I worked on a few years ago. So those are axes, like very primitive axes that were generated via 3D photogrammetry. So they are very nice, with nice colors. As I said, once you have opened the file, you have the file and its contents that appears in the database tree. You can select an entity and you will see all its properties, like its the bounding box dimensions, the number of points, whether it has colors or it could have scalar fields. We'll see that later. Normals. I think it has normals, yeah. So surface normals. One interesting thing is that once you load a file in CloudCompare, you see the top group, which contains all the entities that CloudCompare found in the file, as the name of the file, but CloudCompare won't keep the file open. It won't modify the file. If you do, if you transform the point clouds, if you segment it, if you apply any process, it won't change the original file. You have to save, to export the entity once it has been modified on your own. It won't be done automatically, which is a good thing because you can mess with your data and you won't lose your original file. We won't tamper with the original data. But the counterpart is that if CloudCompare crashes, hopefully not too much, but sadly it happens, you will lose your work. So it's always a good idea to save your data, your entities quite often, just in case. We don't have an undo feature, to undo your last actions, sadly. That's something that has been requested quite a lot, but yeah, we know how to do it, but sadly we really try to optimize the memory there, so we don't want to duplicate the data in memory and stuff like that. So we made the choice a long time ago not to add the undo feature. So you have to manage it yourself. Just save your data from time to time. That's a good habit. And to save it, just select, highlight one of our several entities and hit the save button here. I think there's a Control S shortcut. Okay, so that was one entity, one point cloud that I loaded from the bin format. No question from CloudCompare because CloudCompare knows perfectly how to manage the bin format. So now I'm going to import another file, which is an ASCII text file. So the same way as before, you don't see it, but I'm dragging and dropping the file from my Explorer. So ASCII files can have quite a lot of internal organization. So CloudCompare will let you will try to detect you know, the separator. Is it a white space, a comma, semicolon? It should normally detect it on its own, but you can change it just in case. It will also try to understand which column correspond to which you know, which feature of your point cloud. So once again, yeah, CloudCompare, I think he did a pretty good job of guessing that those are coordinates X, Y, Z. Of course, you could change that if it's Z and Y are inverted, for instance. Then the colors, and then yeah, some normals. When you're happy with that, you can click on the apply button. So ASCII files are a little bit slower to load. By the way, yeah, I know a lot of people are using text files because they are very simple to read. However, they take a lot of place, so a lot of, yeah, it makes very big files very slow to manage. So I think it's better to use other formats, but yeah, I understand the need. So now I have my two axes. There are two, yeah, from different tools, two different axes. They were generated by yeah, photogrammetric process, so they don't have the same scale. So one thing that we'd like to do here for this example is to register the two axes and to give them the same scale. To be able to compare them, for instance, in the end. So there are several options to register point clouds or meshes in CloudCompare. So yeah, yes, they are very dense, but they are point clouds. If you don't know, you can change the point size, displayed point size here when you hover the mouse in the top left part of the 3D view. You can also control the point size for each entity separately. If you do it like that, it will apply to all the entities at once, all the displayed clouds. Okay, so now we want to register those point clouds. As I said, there are several options. You could do it manually with this tool here. Which is very simply named Translate and Rotate. Just highlight one or several point clouds, hit this button. You will see in the top right corner of the screen a sub dialog for this tool appear. It's something very common to CloudCompare. A lot of tools involved, you know, involving some interactions with the entities will work like that with their dialog embedded in the 3D view, and letting you, yeah, work and apply something. Yeah, I mean interact with the clouds. Sorry. So this is the interactive transformation tools. It lets you rotate and translate the clouds, the highlighted ones. So you could play like that. Try to make the two entities fit very roughly. It can be useful for if you just need a rough alignment, if you want to use the kind of automatic alignment tool, which is the ICP registration tool, you have to make the two clouds roughly align first. So this is a very simple way to do. If you pause the tool, you can then change the 3D view, move the 3D view, unpause the tool, transform the entity again, and do it as many times as you as necessary. And where you are done and happy with the results, you can click on this green check to validate the transformation. So when you do that, it will actually transform the point cloud. So it will transform the coordinates of the points. It's not a kind of virtual or display transformation. It's really all the points in memory have been transformed. So if you save this cloud, it will have different coordinates. from the initial one. So yeah, if you overwrite the previous file, just keep that in mind. If you want to go a little bit further, you see that when I applied the transformation, when I validated the tool in the console, so this is an interesting part of CloudCompare. This is CloudCompare will output a lot of information and will try to communicate with you from time to time. So you'd better take a look at it from time to time. And in this case, I got the 4x4 transformation matrix, which can be useful because you can copy it, for instance, with Control-C, and you can reuse it, for instance, in another tool, which is named the Apply Transformation tool. You can use it somewhere else, of course, in another context. What else? Yes, another way to see, you know, as you from the time you loaded the entity to the time you are actually exporting it or using it for a specific process, you may have applied a lot of transformations. Not only with this tool, but yeah, of course you can use this tool several times, but you could also use other transformation tools. And you have at the bottom of the cloud properties this transformation history, which basically gives you the transformation, the total transformation you applied since you opened the file. So this can also be useful. Another way to do scale, to register at least roughly, but also to scale the entity is the Align tool. So this is a very interesting tool, quite common actually in its way it process. Basically, you have to acquire equivalent pairs of equivalent points. At least 3. The more you have, the better generally. Let me show you how it works. So basically, you have to select at least 2 clouds. No, sorry, 2 entities. It works also on meshes. And you can mix, of course, clouds and meshes. So you need to highlight the entities you want to align. Then you can start the Align tool. There, CloudCompare will ask you to choose the align entity. You can not. I mean, you are not obliged to select an entity. In this case, you will be able to register the entities with points that you input, like typically a ground control point from a GPS or something else. So that's this tool can also be used to georeference entities. But here I'll just demo the standard alignment mode. So I'm going to register my second cloud here, the second axe. So I chose it as being the Align tool. So once again, you can see that the tool has opened its dialog in this, over the 3D view, and I can still interact with the clouds. So now the aim is to acquire equivalent points in both clouds. The thing is that you have to acquire them in the same order. So let me try. I haven't tried it in a while. I'm going to do something very rough and try not to. Yeah. So that's a bit strange, but basically you have to reproduce the same picking process to acquire equivalent points on the other cloud. So very roughly, let me look again. Where was my other point? Here. And the last one was, oops. Yes. So you should pay more attention to what you do than what I just did. Yeah, the aim is normally to get the point, yeah, widespread all over the cloud if possible. The farthest the points are, the more robust generally the registration is. When you pick the points, as soon as you have at least three pairs, you will see the error contribution of each pair. You can hit the align button. So it has actually moved a little bit the axes, the axe heads, sorry. Well, I should have picked some points on the tip so as to make things more robust. So let me do that like that. And like that. So once again, this is very rough. Okay. Sorry, I spoiled things a little bit. I wanted to show that, yeah, by default, if you click the align button, it will try to minimize the errors on all the pairs, and it will apply a rigid registration, sorry. But you have the option to adjust the scale, in which case you have the rigid registration with a different scale, so as to get a much better matching. So this is very interesting when you work with photogrammetric point clouds. If you don't have the scale, I mean, you would need, of course, one cloud, maybe coming from a laser scanner or something which has already been scaled, and you can use it to rescale other clouds or equivalent, clouds from the same entity, same building, but generated in another way. So yeah, so you see the RMS at the top, so as to know how good your registration is. You see the error contribution. You can remove pairs if they are too bad, if their error contribution is too big. And you have other options, but I probably don't have the time to speak about them. Once you are happy, just click on the green check, and same thing. Oh yeah, you have a small report that states, you know, how good the registration was. It's only computed on the pairs, by the way, not on all the points, and then the scale, 1.40. Okay, so now, thanks to this process, I have my two axes, which are more or less, in the same orientation and with the same scale. So I think I don't have that much time, so let me go very quickly. From there, I would typically compute the distances between the two point clouds. This is, after all, what CloudCompare is meant to do, at least originally. So same thing, same as the align tool. Just highlight the clouds you want to compare. So either two clouds, two meshes, or one cloud and one mesh. Here, I will use the cloud-to-cloud distance. Once again, I have to select which cloud is the compared one and which one is the reference. So I keep the same reference and same compared cloud as previously. So this is the distances computation dialog. Mind that CloudCompare performs some very rough calculations first for its internal needs. Those are approximate distances. Yeah, I added a warning because I saw, sadly, some people using this kind of results even in some articles. So really never use these distances. They are super approximate. They are mostly used for internal purpose. You basically generally don't need to change the parameters. One interesting feature is this local modeling option. I don't have the time to go over that, but it's meant to cope with issues, with density issues. If your reference cloud density is not the same all over the cloud, or if it's too low, computing distances between two clouds might give you some errors due to these density issues. So in that case, you can use some local modeling. Here the clouds are very dense, and I want to keep things simple. So let's go with the default parameters. Just be sure to hit the compute button. And here now I have, much more refined, accurate, hopefully, distances. Once it's done, you can click on the OK button to close the dialog. So now let me hide the reference cloud. Oh, sorry, this was the reference cloud. And my second cloud now has what we call a scalar field. So it still has its original RGB colors, but now it has this scalar field, which is actually just a set of values, one value per point. It could be anything. Here is distances, but it could be curvature, roughness, or anything. CloudCompare has a lot of options to display scalar fields. You can have as many scalar fields as you wish on a point cloud. You can change, of course, the way the colors are displayed. You can display, which is quite standard, the color scale. You can define your own color scales, change the dynamics, also filter the points by inside a given range based on thresholds. You can also export the points based on those values, like segment the point clouds based on the values of scalar fields, and so on. I think I'm almost done. Do I have more time, or should I stop?
We're actually nearing the end of yours now.
Okay.
We can have some time for a question.
Yeah, I think it's better. Thank you.
Great, thanks, Danielle. So we have a question here from the audience. For CloudCompare, how do you deal with point clouds that have a lot of noise? What is the combination of filtering data we have to use? Noise filter or SOR, or both of them?
Yes, that's interesting. So if I may, I load another cloud to answer this question. Yep. So this is a free point cloud that you can find on the internet. I think it's super cool. It's a Japanese castle in Kakegawa. And they made all the data available on the internet. So this is a very typical point cloud. If you look only with the colors, it looks very nice. Well, it's quite nice actually, it's quite clean. But if you remove the colors, and we have this shader in CloudCompare, which is named EDL, which is really cool, which is very helpful to look at data, especially if you don't have colors, but also it gives you the kind of, it highlights, enhances the microgeometry, and it's very good to see the noise. And here you can also see the spurious points, quite typical from laser scans. So typically from there, the way to go at the beginning is to use the SOR filter, as the question says. SOR is for statistical outliers removal. It's a tool coming from the PCL library. It's very standard. I won't detail too much, but yeah, it's simple and generally efficient. You have to take care about one parameter, which is this one. So basically, you say how many points you want to use for the to compute a kind of neighborhood around each point. And among these points, we are going to look at how different the current point is from its neighbors, and to compute how different it is, and therefore it may be noise. It's all about the standard deviation of this point to the average of all its neighbors. So if you take one standard deviation, it's really for very noisy clouds, so because basically you say that only 65% of the points will remain. All the others will be removed. If you have, the 2 and 3 sigma rules, 2 sigma rules is for 95% of the points, and 3 for 99% of the points. So here, since my cloud is quite clean, actually, there are only a few noisy points. I will prefer to use three standard deviations so as to keep most of the points. Only the real outliers will be removed. So this tool can take a while depending on the size of the neighborhood, but generally it goes pretty fast if you keep it small.
Daniel, thank you so much for your response and for your fantastic presentation. I've been using CloudCompare for a while and I learned a lot today.
Okay, cool.
I would like to invite our next speaker back to the webinar. We have Arnadi Mordioso, and I'm hoping that his presentation works this time. Arnadi, are you there? Ah, there's an issue with the mic. Okay, Arnadi, you should be good now.
Yeah, thank you. Yeah, sorry about that. I didn't know what happened, but let's hope that this time it works. So, so you see my screen over here?
Yes.
Okay, great. And please, will you tell me if there is any if it crashed again, and so I will know that.
Yes, we will let you know if it crashes.
Okay, thank you. So, okay, thank you again, and sorry about that. So, as I was saying, my presentation is about MicMac, and MicMac is actually a photogrammetric software which is open source, and open source, this means that this is free. And I will be presenting a little bit about the different functions of MicMac, and also a small demonstration of how to use it. So to start, here I have as an introduction the basic photogrammetric workflow. It's very simplified. So essentially in photogrammetry, you have a bunch of overlapping photos, and then you compute, well, the computer computes the tie points between these overlapping photos. And based on those tie points, you perform what in photogrammetry we call a relative orientation, or some also in the computer science, they call it pose estimation, to reconstruct the position of your cameras virtually. And then, of course, since this is relative, there is no sense of space on this on the scene. So what we do is we introduce some kind of scaling factor. It could be points known in coordinates, some distances, GPS on your camera, and so on. And in this regard, what we do is what we call an absolute orientation. So in essence, we give a sense of space to the 3D model that we created from the relative orientation. And then next, we can perform a refinement of these computations. We call this this process the bundle adjustment. And so in this case, we can take into account all of the measurements, the tie points, the GPS coordinates, and so on, and we compute a block adjustment of all of these measures. What this gives is a refined position of our cameras, and once we have the refined position of our camera, we can launch the dense matching computation to get the dense matching point cloud. So this is an example of the dense point cloud, and then from this point cloud we can generate a 3D mesh. So here is an example of a 3D mesh. In the case of aerial photogrammetry, sometimes we can also generate a DEM, or a digital elevation model. And finally, we can project the photorealistic textures on our 3D mesh to create a photorealistic 3D model. So this is the basic photogrammetric workflow. And then I will introduce to you MicMac. So MicMac is an open source photogrammetric suite. It was developed by the guys at IGN, which is the French National Mapping Agency, and is currently hosted by the NSERC in Marne-la-Vallée in France. So why use it? Why do we use it? So first of all, it's free, so nobody will say no to free stuffs. There is a very big list of photogrammetric functions for a lot of applications. So you can do relative orientation, absolute orientation, and so on and so forth. What I also like from MicMac particularly is a metric approach. This means that in MicMac you can define mathematically robust computations in contrast to, for example, other softwares which are more focused on the visualization part. So this is one of the advantages of MicMac. It is also very stable because it works with the command line window. And as an extra, it has some goofy function names, which we will see together in a short while. Where to get it? I have put here the QR code for the GitHub page for MicMac, but I guess if you Google MicMac and photogrammetry, you should be able to find it without any problem. Some examples of projects in MicMac. So this one is this is not my project. This is I took this photo from the MicMac website. It's the Château de Chambord in the Loire River Valley. Quite an astonishing project. This one is the one to the right here is a church in Strasbourg that we did using a drone. And of course, just another example of a terrestrial setup, a statue of Buddha. I have here a small video. So this is a skull, a 2nd century skull, which I processed entirely using MicMac from the point cloud generation up to the 3D mesh and the texturing of the 3D model. There we go. Okay, so some useful tips and tricks for MicMac beginners. So I have to tell you that MicMac, well, it doesn't really have a user interface. There is a graphical user interface that I urge you to look into if you want, but I find it more flexible to work using the command prompt. But what I usually do is I use template batch files, which I will show you later, and this makes it much easier to use MicMac. You should start by using the main functions because, as I said, there's a very big list of functions, more than 100, I think. So you should start with the main functions, which I will describe a little bit later. And then you can explore for other specific issues if you want. There exists a very, very useful wiki with this link over here, which I encourage you to read and also to use as your reference every time you want to use a MicMac function. And I must admit that the wiki is very, very useful when you start with MicMac. And if you have any questions, do not hesitate to ask in the MicMac forum. So we enter now with how the photogrammetric workflow in MicMac is represented by the functions. I call this the menu of the day for reasons that you will see soon. So here we have the type point generation and matching. In MicMac, the function that does this is called tapioca. Evidently inspired from the same name food. Relative orientation is managed by tapas, of course, also based on the same named food. Absolute orientation, there are several functions that manage this, so I don't know why the developers didn't find a food that corresponds with these, but it doesn't matter. So for example, here you can use this function if you use a scale bar to scale your model. You use this one if you use GCPs, ground control points, but you can also use this one if you have embedded GNSS or GPS on your camera or drone. For the bundle adjustment, they named it Campari, which is a kind of liquor. And then for the dance matching, they used the function name of Pims, which is a brand of biscuits. For the meshing part, there are two. So you have the tie punch, which is a type of cocktail, which is used for the Poisson meshing to create the mesh, 3D mesh. And if you want to create the DEM, the name of the function is, I guess, Pims to MNT. That's quite straightforward because MNT is French for DEM. For texturing, we use the finally named tequila. And for the orthophoto generation, we use Tony, which is a type of Porto wine. Okay, so just to make it easier for you, I also have here a table of some, let's say, a photogrammetric software, both commercial and open source. And here, so for example, I use a lot Metashape. So if we use Metashape as a reference, when you do a line photo in Metashape, essentially this corresponds to tapioca and tapas in MicMac. And then usually in Metashape, you use the markers, you put the markers on your photos, and then you do optimized cameras. This is actually Bascule and Campari. To build the dense cloud, you use the Pims, and to build the mesh, the types, and so on. So I put here also some others like Photomodeler and Pix4D, Visual SFM, Meshroom is also interesting if you want to look into it. Yes, so this is that table. Now I will show you a small demonstration. So let's see if this works. So first of all, if you download the MicMac from the GitHub, you will get this. So you don't need to install it. You just need to unzip it, and that's all. And all of the MicMac functions is actually located here in the folder bin. And what I usually do is I put a new folder called projects, where I put all of my projects. So here, for example, I have the SEU. This is the one that I'm going to demonstrate to you. This is my project. And inside I have, this is a very small sample of the images. It's the images of a temple in Indonesia, in Central Java. So this was taken using a drone.
I don't think we're seeing the screen that you're referring to. We still see the PowerPoint.
Okay, so I don't know how to do that. Should I close it? Do you see it now, or?
You've unshared your screen, so if you just want to try sharing it again and then click.
Yeah, actually I have to share it. Okay, I see the problem. Okay, do you see it now, or?
Yes.
Okay.
Yes.
Okay. Sorry about that. So as I was saying, so you didn't see the one I saw. Yeah. So this is the MicMac folder that you get when you download it. So I told you that in the bin folder you have all the functions of MicMac, but we will get to that later. So here I added just the projects folder in which I store all of my MicMac projects. Here I have the same one, the one of the temple that I told you about. So these are drone photos. I think they were taken using Phantom 4 RTK, I think. So I just use like 20 or something photos just to show you how it works. And I have here, for example, the embedded GPS. That is the GPS coordinates of the drone, of each camera. I also have the GCP here, just 3 for an example. And this is the important one, is the batch file. So the batch file is where we work with MicMac. And I don't know if we can do it later, but if I can share this to anyone who is interested. So if you open it, you can open it with, you know, Notepad, or I use Notepad++, but you can use any text software that you have. So here, this is the batch file. So first of all, I set the location of the MicMac functions, which is located in the bin. And you can this is the MM3D. I use this. They put all of the commands under this this function, so you can keep all these two paths. So here, if we refer to my previous PowerPoint, you have the type points generation, use the function tapioca. And of course, the inputs, I cannot explain it to you in detail in 25 minutes, but you can see it in the wiki if you are interested in using a more detailed parameters. So here we have tapioca and then tapas for the relative orientation. We will start with those two. And just to tell you that if you use a double 2 points, I think you can put the other commands in comment. So if I save this, so what we do is we open the command prompt, which in Windows or the PowerShell or anything, and then I go to the location of my MicMac project. Like so. So here I have my projects here. And then I go to save there. And then because we have this batch file already, well, what we can do directly, MicMac start, and it's going to launch the computation. And since it will take some time to wait for the results, in the spirit of any respectable cooking shows, I already have the results for you, which is here, there. And so the result is, you can visualize the result. The result can be visualized in the PLY format, which we can open in CloudCompare, of course. So let's see if I can open it and show you the results. Okay, so Daniel told us that we can drag it like so. Yes. So yes, this is the result of the, let's say, the image alignment, the very first result of the orientation, and now we would like to perform the absolute orientation and so on. So I will go to another one. Okay, so I'll work with this one. So we did the tapioca and tapas. Well, we assume that we did it. The next question is, do you have onboard GPS? Do you have embedded GPS on your drone? If yes, we can use this function, the ORIConvert, in order to convert the TXT file into a MicMac XML file. So we can use this. So I just say MicMac start. There we go. And you will notice that here, so this is my original file in text file. And at the end of this ORIConvert function, I should have another one. Here I have the ORIGeotag, which is the MicMac format. So I can then continue with the absolute orientation using the GCP. So I just use the MicMac start again, and it's going to perform the absolute orientation using the geotagging coordinates. And here you can see all the results of the residuals of the coordinates. Okay, and next, do you have GCPs? So if I have GCPs, first of all, what I do is, again, I have to convert the GCP file, which was a text file, into the MicMac format. So I do this. Again, I do MicMac start, and it's very quick. And next, we can try inputting the GCP. So for inputting the GCP, actually, there is a user interface, which I will show you here. Yeah, so there is a simple a graphical user interface just for putting the GCPs. So we are just going to do this quickly in the interest of time. Loading files. All right. So wait, let me just stop this. Okay, so using this interface, I have 3 GCPs, and I can zoom, and then I can correct the position of the GCP. Oh, sorry, like so. Right-click, validate, and I do this for all of the photos, or just do it a few times, like so. And then for the next GCP, I can use right-click, change image for GCP. Let's see now, GCP 16 is over there. This is a very quick measurement. There we go. And then just for the last one, because we need at least 3 GCPs for it to make sense. This is the next one. Okay, just one last one. There we go. So when you do this, it's automatically saved. So you can safely close this. There's no problem. And if you see in your folder, actually, you will have two XML files which are generated. If you see in those XML files here, the 2D XML, you have the image coordinates of the points that I just clicked. And if you look at the S3D one, you have the 3D coordinates of the points that I just clicked. So let's continue. This is done. So next one, we perform the refinement of the bundle adjustment. So use the Compare, the liquor. Use this, and again, I just use MicMac stuff, and it will perform some iterations. And we will see here, you see here the residuals in pixel for each image. Okay, so if you look here, for example, you have the residuals in pixel and all of the statistics that you would need for your analysis. And if you have, for example, checkpoints, or you want to know the residuals for the your GCP, you can also use this function, the GCP control. And if you use this, it will give you, it will give you this information. So you have the RMS of, this one is the planimetric and altimetric. The planimetric is 9 centimeters, and in altimetric is 19 centimeters, and so on. Of course, it's not an ideal result because I only use a very small amount of images for the sake of time. So next, you can, of course, visualize the camera pose, but I'm not going to do it because I already showed you the result before. The next step is the dance matching. So use the pimps here, and then you can export the point cloud and then create the DEM and export the orthophoto and so on. Again, I'm not going to launch this, but I can show you the results. So let me just close this and show you the results that I have already computed. There. So this is the point cloud, the dense point cloud of the temple generated from the photos. The dense point cloud. There is not much that I can show you except this is the result. And then I can also show you the result of the orthophoto. And by the way, the orthophoto will be used later on for the QGIS tutorial. There you go. So I guess that's about it for MicMac. I know it's very quick and there's a lot to digest, but I guess the best one, if you want to start it with MicMac, is to download it and then look around at the wiki and play around with the main functions. There we go.
Okay, thank you so much, Ernadi. Thank you for the introduction, for introducing us for MicMac and for this great presentation. So I have some questions for you from the participants. So one is the file format of point cloud that will be exported from MicMac suitable with other point cloud softwares like CloudCompare, for example?
Yes, I suppose I answered that question when I did when I showed the result in CloudCompare. So yes, the format is actually PLY, and that's quite a common format for a point cloud. And in any case, what I usually do is I open it in CloudCompare, and then I can export it to any format that I need.
Okay, thank you. And for MicMac, what is the best type of camera calibration for compact cameras, for example, like DJI Phantom 4?
Oh, okay. This one is a research question, actually. So I haven't tested, I haven't compared the different. So the guy who asked this must know that there are several mathematical models for the camera calibration in MicMac. So I haven't really looked into it for the specific case of the Phantom 4, but in my experience, the radial extended is quite enough for most of the cases. I did test it with the Fraser one, and actually it introduced how to say some distortion error. So I don't know yet why this happens, but yeah, there you go. That's the best that I can answer right now.
Okay, thank you. And one last question. Is it possible to combine pre-processing images like Wallace filter and image decolorization to amplify type points detection?
That's a good question. I honestly don't know the real answer to that, but I suspect not really. I suspect not really, because the way that yeah, I guess it depends, because actually the way that SIFT works is that it uses black and white images. So I'm not sure. Yeah, I can't really answer that question. Actually, we have to do tests.
Great. Well, thanks so much, Arnadi, for your great presentation. I actually tried to use MicMac a few years ago, and this tutorial really would have come in handy for me and saved me some time. I would also like to introduce Nefeli Tentoma, the next and final speaker of our webinar. Nefeli graduated from National Technical University of Athens, earning a diploma of Rural and Surveying Engineering. Her diploma thesis was completed in collaboration with the University of Florence and concerned 3D model comparison, point cloud construction from analog data, and online web map creation with GIS technology. Nefeli, please feel free to share your screen.
Thank you very much, Rebecca. 1 minute. Okay, so hello everyone. I'm Nefeli Tentoma, and today I will show to you the basics of GIS with the use of an open source software for heritage applications. First of all, what exactly is GIS? Well, GIS, or in other words, a Geographic Information System, is a framework for gathering, managing, and analyzing data. The characteristic advantage of a GIS software is that it combines the spatial data that are geographically corresponding to the real world and attribute data that provide additional information about the spatial features. For example, in this way, the user is able to visualize the findings of an archaeological site or a monument and associate them with their features. So in GIS, the ability that it has for mapping real-world features and at the same time visualizing their spatial relationship is what makes GIS a really useful tool for heritage applications. There are various GIS systems available, either commercial like ArcMap, or open source like Quantum GIS, Grass GIS, and user-friendly desktop internet GIS. Keeping in mind the low-cost techniques, today I'm going to show you how to use QGIS. For today's heritage case study, we will use the Buddhist temple, which is located in Indonesia. And I will demonstrate some basic QGIS operations like importing raster data, using a base map, creating vector data, working with attributes, basic vector styling, creating actions, and eventually creating a map layout and exporting it as a PDF. So now it is time to use QGIS. Okay, so this is the software's interface. At the top, we can see the menu and several toolbars. On the left, there is the browser window and the layers window, and in the middle, there is the mapping display. So if we already have some data, either vector or raster, we can easily import them in QGIS. For example, today we have a digital orthophoto of a Buddhist temple provided by Hernande Murtilloso, and we can just simply drag it into the mapping display and the orthophoto appears. Another way is through the layer tab. If we choose to add a layer, add the raster layer, and from here we can choose the path and import any raster data. And also we can use the same way to import any vector data if we already have. So in QGIS, it is also possible to use some base maps, for example, OpenStreetMap. In order to do that, we should go to the browser panel at the XYZ tiles, and there is the OpenStreetMap. So also we can use this, drag it into the mapping display. And right now we can see the OpenStreetMap layer, but the orthophoto disappeared. And this is why the last layer is always the top one. So we should drag it underneath the orthophoto layer and the orthophoto appears back again. If we need more selections about the base maps, there is also a plugin which is called Quick Map Services that provides a variety of different base maps. And in order to download it, we should go from the plugins tab to manage and install plugins and just insert the name of the plugin. So let's zoom back to our orthophoto. The specific temple complex has several statues. So at first, let's create a vector layer from layer, create layer, new shape file, which will depict the statues located on the temple. First of all, we should choose the folder that this layer will be saved. It is very important that all the layers are saved at the same folder. So this is the folder that I have already saved, the orthophoto. And now we have to insert the name of the layer, which will be called statues. Save. Also, we should choose the geometry type, which will be a point. And for now, we are okay. And we can see that the new layer has been created at the top of the layers panel. Let's select the layer, right-click, and open the attribute table. As we can see, the attribute table is empty. And right now, we should add some new fields for information. In order to do that, we should enable the editing mode. And right now, we will delete the field that it's already here, which is the ID. We'll just choose it and delete it. And add new fields. For example, we want to have the name of a statue. and the type will be text. Another field could be the height, which I will also choose it to be a text because I want to enter the units also. A new one could be the date of construction, which will be also a text. And also, why not, an image of each statue. And for now, this field will also be text. So we created 4 new fields. We have to save the edits and stop editing. So let's go now and change and modify the image field that we just created. So from the statues layer, we right-click and go to properties. At this panel, there are several options that we can choose. Right now, we need the attributes form. And from the fields, we have to choose the image because it's not a text as we set it at first, but we will change it to attachment. We always have to click apply and then OK. So now, since the attribute table is ready, we can start visualizing and depicting the statues on the orthophoto. We can do that by enabling the editing mode from the toolbars and add a point feature. So for example, one statue is right here. We click on it and a new window pops up with all the new fields that we just added. So we have to add the name, which could be the Eastern Gate Guardian. Let's say that it's 4 meters. Let's say that it was constructed at the 14th century, for example. And now, since we changed and modified the image field, we can choose the image. So these images, I found them online. Okay, this one. So I chose my image, everything's all right, I press OK. And as we can see here, the new point has been created. We can continue with the second statue, which will be, again, the name Western Gate Guardian. Again, let's say 4 meters. Okay, at the same date they were constructed. And again, choose the image, which is right here. Okay, so I save all the edits. A new point was created here. So we are okay. For now, we will save the edits and stop editing. If we don't like the symbol of the points, we can change it. If we right-click on the layer, again, go to Properties panel, there is the Symbology panel. And from right here, there are some symbols that we can use. For example, this one, and we can change the rotation, the size, the color, and the opacity. Well, let's make it a little bit smaller. We can also change the color. Well, why not? Always we have to press apply. And OK. So as we can see, the symbols have changed. And now, if we open the attribute table again, we can see that the information we just added from our points are right here. But unfortunately, we can't see the images of the statues. The solution to this will be to create a new action. So in order to do that, we will go again from the statues layer, right-click Properties, and there is the Actions panel. We will add a new action right here. The type of the action will be open. We will click on Capture Output, and from here we have to choose one of the fields that we need, which is the image, and click Insert. So also one very important thing is that we have to write the description of the action, which will be for now so image. Okay, so as we can see, the new action has been created. We press apply and OK. So right now, if we go at the top, we have selected the desired layer, which is a SANTANA-QUINTERO. And right now, from the actions, we can press show image. And when we click on the symbol, the new image appears. Probably you won't be able to see it, I'm afraid so. But yes, by clicking on the symbol, a new image appears in a new window. That's why you can't see it right now, unfortunately. Okay, so let's continue. Let's say that we want to create a new layer about the complex rows that we can see right here, and it will be a line. So from the layers, we can create a layer, new shapefile. Okay, again at the same folder with the previous one, we will call this SANTANA-QUINTERO rows. Nice. This time it will be a line. Okay. So as we can see, the new layer has been created at the top. Again, we can open the attribute table, edit. We can delete the fields that are already in there and just add the new one, which will be called the number of the row. So press OK, save the edits and stop editing. And right now, if we also choose the editing mode from here, we can start creating our lines from the add a new line feature. So let's create the first one. We right click right here when we're edit. Let's say it's the first row. Okay. Let's go to the second one. Right click. 2. Let's go up to the fourth one. Right click again. 3. And the fourth. Last right click and 4. Okay. So these are the new lines, even though we can't see them clearly. So this is why we will save the edits, stop editing, and we will again go to symbology from the properties. Right here, the symbology. I would like to change my symbol so I can choose this type of the line, and I will apply it. And right now, if we want to classify the 4 different lines, again, on the symbology panel, we can choose here, instead of single symbol, categorized. So we should choose, depending on which value there will be categorized, which will be the number. The color ramp could also change. Let's say it could be spectral. And if we choose the classify button, we can see the 4 different lines representing each temple row. So again, apply and OK. So as we can see, the lines changed. Also, we can make labels on each one of these lines. Again, from the properties, underneath the symbology panel, there is the labels panel. So from no label, we choose single labels. Again, we should choose, depending on which field, which will be the number. We can also change the text of the labels. For example, I can add some shadow right here. Apply, okay. And okay, right now you can't see them clearly. So right here, there are the numbers like 1, 2, 3, and 4. If we want to change the position of the labels, there is this option up here, moves label or diagram. So for example, we choose the 3 right here, and let's do it up there. And we can move the label and place it wherever we want. Also, we could make it a polygon layer. So in order to, so where is the main temple of this complex? Again, from the create layer, new zip file. Again, at the same folder, it will be the main temple. And this time it will be a polygon. Really nice. Right now, we can go again to properties to change the symbology and change the opacity so that we can see underneath the specific one, the details of the temple. We can apply it. And again, from the editing mode, we can add a new polygon right here. And when the polygon is ready, we right click and okay, that's polygon 1. So right here, we can see the new vector layers that we created in order to visualize some of the findings on this temple complex. For example, the 2 stadios, which are points, the temple rows with the lines, and the main temple with a polygon. If we want to create a map layout of this project, we could easily do that from the project tab on top and use the new print layout. First of all, we have to insert a name. So this will be map layout 1. And a new window pops up. On the left, there are several options for creating a map layout. First of all, let's add a new map. So we choose where the map will be, right here. And everything that we can see on the mapping display, we can see it also here on the map layout. Then we can add the legend, which will be all the layers that we have created on the specific project. We can add a scale bar and the north arrow in this way. And also we can add a text for a title for our map. And every time we add something on the map layout, at the item properties, we can modify it and change it. For example, now at the text, if we click on the font, we can change the size of the letters and make them bigger for now. And we can move it around and modify it the desired way. And at the top, there is the option to export as a PDF. And if we click it and we save it, the new, as we can see, the PDF is saved at our desktop. So these are the basic QGIS tools for the heritage applications. I hope that they could help you, and thank you very much for your attention. I will be really happy to answer any of your questions.
Hi, Nefeli. Thank you for your presentation. I'm just going to open up the questions here. Okay, so we do have a question. Compared to some of the other GIS software that is out there, what do you think are the benefits of QGIS, or what makes it different?
Well, first of all, the fact that it's free and anyone can use it, and anyone can open a project that has been created in QGIS. That's very useful. So you can easily create a project and someone else who already has QGIS can see it and can also modify it. So I think the fact that it's an open source software, it's one of the basic. And also I don't believe that all the operations of the QGIS are very simple and user-friendly. And it's very easy for someone to learn how to use it. So I believe these are some of the advantages that QGIS has to offer.
Great, thank you so much. We're going to pass it on to Becca.
Hi, Michelle. Thanks. Yeah, I just wanted to thank all of you for your time today, and I wanted to thank all of the panelists, speakers, and moderators for their wonderful presentations, and the participants for your wonderful questions. In the chat box, you'll see that I posted a couple links. We will be posting the recording of today's webinar, as well as some additional responses to unanswered question and answer on the CIPA EP Facebook page. And again, you can find that link in the chat box. Additionally, we encourage you to visit the CIPA webpage and ICOMOS webpage for more information about these organizations. Lastly, I would like to introduce Grazia Tucci, the CIPA Education and Dissemination Commission Chair, who will provide closing remarks.
Thank you, Rebecca, and hello to everybody. As chair of the CIPA Permanent Commission on Education and Dissemination, it is my pleasure to thank you to have invited me for these conclusion remarks at this second webinar. I would like first to thank the supporters, ICOMOS and CIRC Create Heritage Engineering Program of Canada, and the fantastic organizers, the CIPA Emerging Professionals, for their dedication to work, their energy, and their active questioning about the role of new technologies. I can say that with you, I'm feeling younger. Nowadays, the increasing availability of low-cost sensors, free and open source software, and high-performance computing infrastructure allows geomatics to widen its application scope by stimulating new challenging investigations related to the modeling of the observations provided by these new tools. The speakers have touched some focal points today. The first one, no good results without a good input. So the importance of being comfortable and familiar with your camera and its functions. Thanks to Christian, this is very crucial. Photography is probably the most accessible and the most widely used documentation tool. I always say to my students that images are our measurements. As we need good measurements, we need good images. The second speech, we can say that low-cost technology does not make everyone an expert, and the idea that anyone with a drone becomes a photogrammetrist is not always well considered from the old scholars. The same is happening for multispectral investigation techniques, until recently reserved for a few, and also in this sector, new possibilities are emerging with low-cost solutions. Different spectral bands can be useful for very different heritage applications. It is possible to simulate multispectral data using low-cost modified cameras or even compact off-the-shelf camera. And this new challenge involves us personally, I mean, who have dealt with photogrammetry and the 3D modeling up to now, and is entering a new field. So the question is, will we also be able to correctly interpret the new information collected by these sensors? About CloudCompare presentation, who work with the measurements know that whatever tool is used, the evaluation and validation of the results are a mandatory step. For this reason, CloudCompare is in the toolbox of each of us. But CloudCompare, it is also much more. In this case, it is not the low-cost alternative to more famous commercial products, but it is really one of those few free and open source software, well-known and also used outside the circle of specialists, with sometimes unique functions. It is essential to identify new techniques capable of easily providing low-cost and real-time 3D models. But I would like to underline with the required accuracy. We know that 3D models can easily provide answers to scientific needs in a lot of contexts. Results are very promising, paving the way to a wider use of a 3D digital contents. Like many things, photogrammetry software comes in many shapes and sizes. MicMac is a free open source photogrammetry software. Its sophisticated feature set is mainly suited to professional or academic user, but it is also accessible to general users. These are, in my opinion, the strength and the weakness together. Finally, the last speech, Nefeli. I am happy to have seen you here. She was in Florence last year. She talked about basic tools of QGIS for the visualization of an archaeological site. We all know that development of a free and open source is therefore a topic of a great interest for the managing of the data, and that we all have to deal with GIS. So thank you, Nefeli, for your clear presentation. And now some general consideration. Low cost is fascinating because if I can do something by spending less instead of spending more, of course I'm happier. It also means that when something intrigues me and I want to try to face it, if I have to do a big investment, I can decide to retrace my steps, perhaps losing the opportunity to expand my skills or to improve my way of working. When we talk about low cost, referring to geomatics, two components should be taken into consideration: hardware and software. If we consider laser scanner and photogrammetry, in both cases, we need hardware, the camera, the laser scanner, and software. Nowadays, as far as hardware is concerned, this battle is won by photogrammetry, but precisely it is only a battle and not the war. We also know that when technologies become mature, their costs tend to go down. Today, we have had the opportunity to verify that low cost does not always mean low quality. In particular, when low cost is a consequence of open source, such as MicMac or QGIS, it is possible to control projects in an excellent way, also from the point of view of the accuracy of the results. Often, open source projects are born on the margin of the academy and are not driven by the intention of supporting professionals in their work. But both examples we have seen have become over time fundamental tools both in the scientific and in the professional world. Low cost today also has another variation, at least in the world of 3D digitization, that is in the gray area between photogrammetry and the laser scanner, where hybrid systems and the range cameras have also been operating for some times. There are a lot of software, free or very cheap, so simple to become apps for our smartphones, which can be used to create 3D models by anyone. I do believe that they should not be viewed with too much suspicion, thinking of the poor quality of the results they produce and the tool carelessness to metric aspects. Really, they offer opportunities for contamination, for capturing the interest of those from distant worlds. Moreover, they can be training tools, albeit at an introductory level, particularly useful in this period in which we are forced to give lessons remotely. Students cannot access our laboratories these days. We cannot organize work on the field as we have always done. Offering them the possibility of carrying out the practical activities on objects they can find at home and developing 3D models with consumer-type camera at the limit with their smartphones and the low-cost software brings our courses back to their original dimension of learning by doing. We have always believed that the quality of a product is directly proportional to the resources, also economic ones, necessary to obtain it. Today, we can say that things are different. High cost does not guarantee quality, and that high quality can be achieved with low cost tools. In this scenario, we need to be re-evaluated. Are therefore professional skill, what we need to be re-evaluated are therefore professional skills, which becomes the discriminating element for the quality of the results. And the emerging professionals who organized this meeting are a shining example. So, thank you.